Hey everyone, thanks for joining me for another Powershell tutorial. In today's video we're going to be discussing conditions that we can add to our commands to further improve the quality and the meaningfulness of our data output. We'll also look at the pipe symbol, we'll look at the select object way of adding a condition and the where object way of adding a condition, and there's plenty of other ways that we can add conditions, but these will be some of the more common examples that you'll use in your scripts and your commands. So first of all, if we take a look at the script that we ran last time, we will keep the content, but we'll look to see if we can hide it away somewhere. And as you know, if you watched the last video, we can add the hash symbol in front of every line to make it a comment. It turns green and it is no longer run when we run our command. So if I run this script now, having commented out the first couple of lines, instead of getting these 4 lines, I should only get 3. Sure enough, I only get 3. Where it's quite cumbersome to type in the hash against every single line every single time, there is fortunately a shortcut. We'll get rid of the top line, we'll put an open bracket and follow it with the hash symbol. We get a load of squiggly red lines underneath our text, which has now turned green to show that it's a comment. The red squiggly lines are actually telling us that there's an issue with our syntax, and that particular issue is that we've not yet finished off our block of comments. So this is a comment block, we add another hash at the bottom, and then we put more than symbol, and now we have a comment block. And you can see a little minimize button, which if I hover over it, it highlights the entire block, and we can minimize that and hide that away, and now it won't run. So let's take a look at some simple conditions that will help us improve our PowerShell scripts. As you might remember, in the last video we simply just output a count of the directories and files, and those that were hidden and those that were visible. Perhaps what we want to do this time is to look for particular strings in file names or particular file extensions where we can do all of this. So we'll start off with the familiar getChildItem, and we'll point it to the variable which has got the path to count files and folders, and we'll just run that as is just to the program files. And you can see on the left shows us the mode, which is all of the attributes, and all we've got is directories that are visible, hence the D showing there. If I then add, let's do it here, getChildItem, and I add hidden, I'll see just the hidden ones, and some of the hidden ones have got other attributes. Desktop ini doesn't have the D attributes, it's not a directory, it has an A attribute, which means that it's an archive, but it's the little hyphen at the beginning where the D would normally be means it's a file. The H means it's hidden, S means it's system. If we change hidden for recurse, we can then go through all of the subfolders, looking at all the files and subfolders there. We'll change our folder to Microsoft Office. We can see in there we've got some other folders and some additional files. We'll see what happens if we recurse that. So quite a lot of files and folders. Let's change our command to say recurse, and we'll also count how many items there are. So 6,430 items. So maybe what we want to do is get the full name for everything, but we don't really, especially if we're testing a script, we don't really want to get all 6,430 items looping through every time. Well, fortunately, one of the things that we can do is we can add the pipe symbol, which is the vertical line I've just typed in there. On the UK keyboard, it's bottom left of the keyboard to the left of the Z key. On a US keyboard, it's normally the key that's left of the enter button. So we'll put the pipe symbol in and we'll say select object, and we're going to tell it we want the first 15 items. Let's run that now, and sure enough we only get 15 items back. So that's a lot easier to manipulate and kind of play with. However, if we take off the full name part and run that again, we can see it lists it by directory. So clearly the first 15 are made up of a number, maybe 7 or 8 in the first directory, 1 in the second, so on and so forth. So of course when we put the full name it was just easier to view everything by its location. But perhaps what we actually want is the name, and we can see we've got some other things like last write time and length. So I'm going to say we want to also select the object name and last access time, and let's see what we get there. And sure enough, I've now got just the names and the last access time. You might be thinking, how did you know to put the last access time? And one of the things that you can do is to use the pipe command with your getChildItem or any command, and after the pipe type in getMember, and getMember will actually show you all of the available members of that particular command, i.e. the things that you can pull out. So if I do that, we can see I could have chosen full name. Extension is perhaps a good one, I could have chosen that one. So let's do that. Let's do full name and we'll choose extension. And here we go. So we can see we've got lots of HTML, EXE, XMLs, so on and so forth. Well, that's all very well and good, and you can certainly see a lot more information about the files, but perhaps you don't really want anything that's an XML file. Perhaps there's a lot of XML and you're not really interested in XML, you're interested in other things, or more specifically you only want to see the executables, the ones that are .exe. Another way that we can add conditions to that getChildItem command is to use the whereObject condition. So if I put in whereObject, and the notation here is we have a open kind of squiggly bracket and we close it, and within that we put our condition, which we're going to put $_ to begin with. $_ means the current line item. So if you imagine getChildItem is running through each of these directories and files recursively, and this is line item 1 where it says data, line item 2 is Office 16, and so on and so forth. Every single one of these line items, the whereObject is going to be looking to see if there's a match for that condition. So we haven't specified any yet, but we could, for example, say we want it where the object matches, let's say, exe. We need another pipe as well to tell it to do the next bit. So if we run that with whereObject match exe, and still have the first 15 and still the full name and extension, we should see that all of the extensions are exe, and that the items on the left are slightly different because of course we're going to be omitting things like appmanifest.xml, which doesn't match. Let's run that now, and sure enough it does match. However, you'll notice that not everything is an exe file. This file here, for example, is actually a .manifest file. However, in the file name we have .exe. So the match condition will match any part of that file name at all, because we've specified just the item itself, just that line item. So that can be the file name, file extension. What we could do is add .extension to our condition, so now the object's extension must match .exe, and when we run that again we'll see that now all we have are .exes. And conversely, you can also put the opposite or the negative to that, so we could say where it doesn't match exe. So now I'm expecting all 15 to not be .exes, and sure enough they're not. So hopefully you found that useful and interesting, and in future videos we'll expand on this even further, and we'll look at our original script and see if we can do other clever things with it to tidy it up and make the output of it more meaningful. So until next time, thanks for watching.